Hi everybody, so this is the video for section C, which is matrix multiplication. So a couple of notes before we sort of dive into what this is all about. In the previous video when we talked about addition and subtraction when it came to matrices, they had to be the same shape. When it comes to multiplication, your matrices do not need to be the same shape in order to multiply them. And I have multiply in quotation marks because the process that we're doing here is not as straightforward as multiplication you've been doing for years. This is a bit more of an involved process. So multiply, it might not be the best word, but that's what we're going to go with. Even though they don't have to be the same shape, you cannot multiply together any two matrices. And I put here order matters. So you're not going to get the same answer if you multiply matrix A by B as you do if you multiply B by A. And that's sort of going against what we know about multiplication, because for years we've said, well, 2 times 3 is the same as 3 times 2. But that's not the case when it comes to matrices. So I have a couple of examples here where I've got matrix A is a 3 by 2 matrix, matrix B is a 2 by 1. So if we are going to go A times B, these two numbers on the inside have to be the same. So the number of columns in matrix A must be the same as the number of rows in column B. And if those numbers are the same, you can go ahead and multiply them. Incidentally, the shape of the matrix you will get at the end of the multiplication is your other two numbers. So if we multiply this matrix by that matrix, we would get a 3 by 1 matrix when we're done. Just a little, hey, isn't that neat kind of point. But if we take those exact same two matrices and reverse the order of the multiplication, all of a sudden these numbers in the middle are no longer the same, and we could not do that multiplication. That would be an impossible matrix multiplication to do. Okay, so we'll start with two matrices that are identical in shape, because that's sort of a good place to start. Now, this looks a little complicated, and I get it. Let's walk through it sort of step by step. So we've got matrix A, and I've just put in A, B, C, D in place of the numbers that would normally be in that matrix, just so you can kind of follow what's happening. And then matrix B, we've got W, X, Y, Z. So because those are both 2 by 2s, we see that those middle numbers would be the same no matter which order we do this in. So we can go ahead and multiply those together. So here's the process of how to multiply together two matrices. So you're going to see A times W plus B times Y. So where does that come from? So I want you to think about the position of this value in the matrix. This is in row 1, column 1. So in order to generate this number, we are going to multiply together row 1 of the first matrix, AB, by column 1 of the second matrix. So we're going to go A times W plus B times Y. And that's going to give us like element in row 1, column 1. And then it becomes your choice whether you want to move across or whether you want to move down next. It doesn't matter. You're going to get into a bit of a rhythm of what you kind of prefer to do next. I usually would go across, but I could be just as likely to go down. It really doesn't matter. So if I go across, now I am in row 1, column 2. So when I do my multiplication, now I'm going to multiply together row 1 by column 2. So I'm going to go A times X plus B times Z. Then if I move down here, now I'm in row 2 of column 1. So I'm going to multiply together row 2 and column 1. So C times W plus D times Y. CW plus DY. And then moving over here, this is row 2, column 2. So I'm going to multiply together this row with this column. So CX plus DZ. And then I would do those little expressions to figure out what the actual final numbers would be. So my final matrix would be a 2 by 2 matrix, because these would all sort of reduce down to single values. So let's do some examples with some actual numbers in them. So now that you've got sort of the gist of the process, let's get to some real numbers. So I've got matrix A here, 1, 2, 3, 4, B, 5, 6, 7, 8. Try to keep it simple so we can kind of see where the numbers are all going. So the first way we're going to do is we're going to do A, B. So I'm multiplying A times B. All right, so I start with row 1, column 1. So I've got 1 times 5 plus 2 times 7. So that's going to be my first value. Then if I move across, I'm in row 1 with column 2. So now I've got 1 times 6 plus 2 times 8. And then if I move down, I'm now in row 2 with column 1. So I've got 3 by 5 plus 4 by 7. And then last, I've got row 2 by column 2, so 3 by 6 plus 4 by 8. If you'll notice something, the numbers that come second are the same because you're multiplying everything in this one by column 1 because these ones end up in column 1. And then if you look across, the first numbers in both of those are going to be the same because we're multiplying the same row by different columns. All right, so I'm going to throw those in some brackets, and then I'm going to start working these out. So I've got 5 plus 14, so that gives me 19. I've got 15 plus 28. What does that give me? 38, 43, I think. And then if we move over here, then we've got 6 plus 16. 22. And then we've got 18 plus 32, so 50. Put that all in a set of brackets, and there's my final answer. Some of you might be comfortable writing in that line of work where you actually just work out the multiplications and then do your additions finally. When you're asked to do these by hand, you need to show this middle step. We need to be able to see where your numbers are coming from. We need to be able to see that you've got the numbers in the right places. So this middle step is essential. You cannot just jump from there to there and expect full value. So if we reverse the matrices, and in this case we do B times A, this example is just to show you that you're not going to get the same result. So order does matter when you're talking about matrices and multiplying. So again, row 1 by column 1. So 5 times 1 plus 6 times 3. And then if I move over, I've got row 1 by column 2, 5 times 2 plus 6 times 4, 7 times 1 plus 8 times 3 to give me row 2 by column 1, and then 7 by 2 plus 8 times 4. So row 2, column 2. Okay, and then I'm going to work these out. So 5 plus 18, so 23. 7 plus 24, 31. 10 plus 24, 34. And 14 plus 32, 46. Okay, so that's a couple of examples of matrix multiplication where your matrices are the same. So I want to do a few where your matrices are not the same shape, just to kind of show you how those ones work. All right, so 2 new matrices. We've got P and Q. So first we're going to try multiplying together P times Q. So we've got 1, 2, 3, 4 by 5 and 6. So this is a 2 by 2, and this is a 2 by 1. So P times Q is fine because you've got the same number on the inside. So incidentally, our final matrix is going to be a 2 by 1. Okay, so row 1 by column 1. So 1 times 5 plus 2 times 6. And then we don't have any more columns, so we're not moving across. The only place to go is down to do row 2 by column 1. So 3 by 5 plus 4 by 6. And then if we simplify those out, we've got 5 plus 12, 17, 15 plus 24, 39. And then if we look at the reverse, if we look at Q times P, now we have a 2 by 1 multiplying by a 2 by 2. And all of a sudden, those middle numbers are not the same. So we cannot do this multiplication. So this is impossible. It cannot be done. Okay, so the one last thing that I want to do is I want to show you how to do matrix multiplication on your calculator. It's a good way of checking your work. If you're in a calculator section on a test or on an exam or something, you could absolutely use your calculator to do the entire thing. If you're not, then you're going to have to do this by hand. So I'm going to tackle this question done on the calculator. Okay, so turn it on. So the first thing you need to do is you need to look for this matrix menu. It's right above the x-1 button. So you're going to go second function, matrix, and then you get this matrix menu. You get names, math, and edit. First thing you need to do is go over to edit. Edit means you're going to input some matrices. So I have a bunch here that were in from doing some previous things. It's fine, we're just going to completely overwrite them. So I want to have number 1 highlighted. So I hit enter, and then the first thing it asks you to do is enter the order of your matrix. So I'm going to put this one, actually maybe I'll do it in the same order. I'll do A is A and B is B. So I'm in matrix A, so it is a 2 by 2, so I'm just going to enter through that. If you needed to change numbers, you just input the numbers. And then it's going to ask me to fill in the elements. So my elements are 1, and then it goes across 2, 3, 4. So just do a quick double check and make sure that the matrix looks how you want it to look. So this is matrix A, so I'm good to go. Then I need to go back to the matrix menu again, arrow over to edit, and now I want to edit matrix B. Hit enter, so I have a 2 by 2, and so then I'm going to enter 5, 6, 7, and 8. And then to do anything with your matrix, you need to completely get out of this menu. So I'm going to go second, quit, to get completely and entirely out of that menu, back to a main screen. So what I want to do is I want to do B times A. So the way that you do that is you need to call back the names of the matrix. And in order to do that, you get back into your matrix menu. And now I want the name of the matrix. So I want B times A. So I'm going to arrow down so that I'm on matrix B. I'm going to hit enter. And it pulls matrix B back to my main calculating menu. And now I want to multiply that. So I just hit the multiply button. And then I'm going to call back the name of matrix A. So back into the matrix menu, select A. So now I have B times A. And then I hit enter, and then it gives me the answer to that multiplication. Calculator is really slick. You need to be able to do it both ways though, and that's really important. Okay, that about does it for matrix multiplication.